Welcome to Unit 2, Introductory Chemistry on Stoichiometry. The word stoichiometry, you can pronounce it in any way you want, but what is important is what does this stoichiometry talk about? In simple terms, stoichiometry simply means it's the calculations that are involved in chemistry. Calculations are different depending on where you are. You can calculate the number of years, you can calculate the term. If you are bankers, they'll be calculating about the money. What about the chemists? What are you talking about? When it comes to this, the cardinal point we are talking about, all these calculations, they will be involved using the atom from the unit 1 that we talked about. So all the things that we'll be doing in the calculations be based on from what we did in Unit 1. So we are going to involve again the atoms. This time I'm going to introduce you to a very, very powerful tool that a chemist must have. For example, if you're a hunter, you cannot go and face the lion in the bush if you do not have a very vital tool, which is a gun. And even us, as a chemist, the one that is very, very vital when it comes to the calculations and the way, wherever you are, you must have a periodic table. And the periodic table, it is where I'm pointing at right now. It's a must that every one of you must have a periodic table, or you must have the access to the periodic table. Now somebody might ask you, what is involved in the periodic table? It's just, it consists of elements. And these elements, they are arranged according to the increasing of the atomic numbers. Now, I'll define what is an atomic number. And if you can be able to check the periodic table, again, it is involved according to the way they are arranged in the horizontal and in the vertical column. So, in simple terms, the periodic table consists of 8 groups. There is group 1, group 2, group 3, group 4, 5, 6, 7. By group 8, we don't just square group 8, we just square group 0. There is a reason, because all those in group 8 or 0, they are innate, they do not involve in the chemical reactions. Now, to start with, before you can go into the actual calculations, you must first of all build up from the atom I will first of all talk about the group 1 element. You can talk of lithium, you can talk of sodium, but I will start with the sodium, because most of the time when we eat, we add salt to whatever we are eating, we always talk of sodium chloride. Now I'll start with the sodium, because every human junkie must have at least talked of table salt. Table salt is sodium chloride. So I will take that element, which is called sodium. So the word sodium, it's a metal which is found in group 1, which we call alkali metals. Now, the way the symbol of sodium, if you check on the periodic table, look the way I've written. It's capital N and small a. Because if you write capital N and capital A, it doesn't make sense. Not even a Avogadro number, because that's not the way we write it. So it's a capital letter N and a small letter A. These you do not need to memorize. You should always be able to, when check the periodic table, you'll be able to look at the symbol Na. So when we write Na, this is the symbol of sodium. When you look at the symbol of atomic number and the proton numbers, the atomic symbol for sodium is that, and if you check your periodic table, you are going to see that there are numbers that are written. For me, because I know it by head, but for you, you do not need to memorize. But as time goes on, it's very helpful so that you should be able to know these numbers. You'll be able to see there at the periodic table. Now, these numbers like 23 and 11, remember last time we talked about 3 subatomic particles. I'll repeat them. These are protons, they are neutrons, and electrons. So here, you're now going to associate these with these numbers. So when you see the number 23 there, what it is now talking about, it is not talking about any other things apart from what is called the atomic mass number. So that number at the top, it is simply saying that it is the atomic mass number. In some books, you find that we are going to represent it by a capital Z. But on the periodic table, you are going to find that we are going to represent it by a small letter A. It's like you go to the toilet, there are so many symbols. They can either write this is female, or they can say this is male, or they can show the dress or whatever. Even here, it is agreed upon. When you see capital Z, I'm talking about the atomic mass number. And in the periodic table that we use, they will use the letter A. Now, if somebody asks you what is the atomic mass number, these are in relationship to the protons, neutrons, and electrons. Simply means the atoms, the nucleus, that is where the mass is concentrated. So when we talk of the atomic mass number, they are simply saying that you remember from what we talked about, the nucleus is made up of these two. So if I add the protons plus the neutrons, whatever number that I'm going to get, that's what makes up what is called the atomic mass number. In short, the mass of an atom is concentrated at the nucleus. There is also another number there, which is 11. We are also going to associate 11 with one of these subatomic particles, and they're just saying that in this 11, you are going to find that it simply means this 11 is what is called the proton number. I'm sure from here you can be able to judge yourself, say that, okay, the protons that are found in the nucleus, there are 11 of them. Now, there is another hidden number that everyone should be able to understand. When you subtract these, the number that you're going to get is 12. This number, it is hidden, but it is still very, very useful. Why? because I've already talked about protons, I've talked about these. So when you subtract these, it means whatever number that you're going to get, that is the neutron number. It has the known symbol, so that what's the neutron number. So anytime when we write this at the back of your mind, when you subtract, then you can be able to say that there is a 12. So I'm going to go over it. When we write the element, like sodium, capital N, small a, this simply means it's the atomic symbol. And in this sodium, the structure, we are going to find that at the middle now, it is elaborated so that the nucleus is made up of two things. It's the protons, meaning in this sodium, it has got 11 protons. The other box, the quantity atomic number. When you subtract this, it will give you the neutron number. I'm going to give you another example. For example, we are used to things like maybe hydrogen. Hydrogen, if you check on your periodic table, it's written 1 and 1. Again, it simply means 1 stands for it's the mass number, and the one which is below here, it's the proton number. And when you subtract here, you're going to find that the number that is 0, meaning when it comes to hydrogen, there is no neutron number. Another one that we can be able to talk about briefly, we can talk about maybe carbon. Carbon, if you check on your periodic table, the symbol is C, and when you look at the top there, the mass number is 12, and below there is 6. When you subtract this, it comes to 6. What it simply means is this. Carbon, the mass number, when you add the protons and the neutrons, it will give you this. And the atomic number, or the proton number is 6, and the neutron is this. So these numbers are very, very important when it comes to the calculations. But we cannot do the calculations. First of all, we should be able to understand how do you write the chemical formulas. In the stoichiometry, there are stages that we should be able to understand. And now, I've moved from the atomic structure, and I'm now going to say, how do you write, for example, the symbol for water? The symbol for water, it is the capital H2 and a 0. Why do we write water like that? What about the common salt, which is sodium chloride? Why do we do this? Again, we are going to go and look at the periodic table. You are going to find the periodic table, it has got elements, and there are those groups that I've talked about, group 1, 2, 3, 4, 5, 6, 7, 8. There is now a correlationship. They are related when writing the formula. Before you write the formula, first of all, you should be able to know what is the relationship between the group and the number that is very, very important. It's cardinal. It is called the valence number. In some books, they don't write the way I've written it, group 1, 2, 3, 4. In some group, they use the Roman way. But for our purpose, let's use what is on the periodic table so that we should not be able to get confused. You remember? Group 8, I said we do not write the 8, we write the 0. So these are very, very important because we are going to look at the other one which is called the valency number. What's a valence number? It simply means these are the electrons that are involved. You remember we talked about an atom is the smallest particle that can take part in a chemical reaction. Now the things that take part in a chemical reaction, it is the electrons. So those electrons that are involved, for example, you and me, go and buy something, what is involved. You cannot go to the shop, I want the bread, then you pray. Prayer, yes, is important, but at times you do not need prayer. What you need is the money. So to go and buy something, you need the money. So even for the chemical reaction to occur, electrons are very, very important. I repeat, electrons. And the electrons that are involved in this chemical reaction, that's now what we call the valence numbers. That makes up the valence numbers. So those that are in group 1, the valence number will be 1. In group 2, it will be 2. Group 3 will be 3. In group 4, it will be 4. But when it comes to 5, it doesn't mean that there are 5 electrons that are involved. There are supposed to be 3 of them. I will come and explain when we start the covalent bonding, where we have got what is called the octet row, the electrons that are involved. So when it comes to 5, we are going to say 3. When it comes to 6, it will be 2. And for 7, we're at 8. And for that one, 0. 0 means they are innate. They do not take part in any chemical reactions. For example, I want to write the formula for water. First thing first, you should be able to identify what are the elements that are involved. The elements that are involved in the water, as far as they are concerned, is a capital H and an O. Now, for me to know how to write the correct formula, you should be able to know to which group does the hydrogen belongs. It belongs to group 1. So, if it's group 1, the valence number is 1. We write it at the top, 1. Oxygen, again, if you look at the way it is, oxygen, if you look at the periodic table, it's found in group 6. And we are saying that group 6, it has got the valence number, meaning there are 2 electrons that are involved. And I'm going to write it at the top there. To write the correct formula, you're supposed to now cross them. And that is how we are going to say it's going to be H2O. It is practically wrong to write this H20. Maybe it's a house number of somebody or a key number, H20. So you should be able to know the way I write it. H, the 2 is below there, and the other one, it is as it is, the capital letters. So these are very, very important. So the first thing in stoichiometry, you should be able to know how to write the what? The correct formula. But to make life easy, at times it's not always, even to get to the first point, at times they're going to struggle. Even us, to get some of these things, we should be able to understand, but practice makes what? Perfect. I'm now going to go to the other group that is very, very important, where next time when we meet, we'll be able to talk about the radicals, but remember, when writing the correct formula, we use the valence numbers, and there is a connection between a valence number and the group number. For now, we end here. The next unit will come and continue.